Good morning, students. Once again, I welcome you to my video lectures on signals and systems. And this is the last class of LTA systems. That is, I will work out one problem on step response, and that ends the LTA chapter. That is linear time invariant systems. And in this chapter, we have gone through convolution sum, convolution integral, and to check the system properties using impulse response, and lastly what is known as step response. Find step response given impulse response h of n is equal to minus 1 to the power of n u of n plus 2 minus u of n plus 3, and these u of n plus 2, u of n minus 3, n plus n minus 3, they are called as shifted step functions. What is u of n plus 2? U of n plus 2 is infinite 1. U of n plus 2 is equal to 1 from minus 2 to infinity. From minus 2 to infinity, u of n plus 2 value is 1. Now what about u of n minus 3? U of n minus 3 value is 1. When you give n values from 3 to infinity. See, for example, give 3, n equal to 3, u of 0, 1. Give n equal to 4, 4 minus 3. Whenever the argument is positive, this n plus 2, n minus 3, they are called argument. Whenever the argument is positive, the value of the function is 1. Whenever the argument is negative, the value of the function is 0. So it counts from minus 2 to infinity. This is from 3 to infinity. You have to keep this in mind before solving this problem. Now write the formula. S of n formula is summation from minus infinity to n h of k. So this is h of n. So replace n by k. Then it becomes minus infinity to n minus 1 to the power of k u of k plus 2 minus u of k minus 3. U of k minus 3. I will split it like this. Minus infinity to n minus 1 to the power of k u of k plus 2 minus summation minus infinity to n minus 1 to the power of k minus 1 to the power of k u of k minus 3. And remember this formula. Summation 0 to n a power k is equal to 1 minus a to the power of n plus 1 divided by 1 minus a. I will make use of this formula. Now I will write the formula for this. Now if you interpret this is u of from u of k plus 2. I said it is from minus 2 to infinity, minus 2 to n, minus 2 to n, from minus 2 to n, minus 1 to the power of k. Its value is 1. Next minus infinity to n. But for this one, u of k minus 3, it is from 3 to n minus 1 to the power of k. Now in the formula, it is from 0 to n. Whereas here it is from minus 2 to n, and whereas here it is from 3 to n. So now what I will do is, first I will take this. Now first I will write the value. So after minus 2, minus 1, 0. Therefore, I will separately write the terms that comes under summation by giving values to k, minus 2 and minus 1. So what I will do, minus 1 to the power of minus 2 plus minus 1 to the power of minus 1. So after minus 1 it is 0 plus summation 0 to n minus 1 to the power of k. Next, minus now here 3 to n. Now instead of 3 to n, I will take 0 to n minus 1 to the power of k. Now I have taken the excess 3 terms, 0 term, n equal to 0, n equal to 1, n equal to 2. Therefore, I will subtract minus. So it is from 3 to 1. But I have taken from 0 to 1. Therefore, minus 1 to the power of 0 plus minus 1 to the power of 1. Next, plus minus 1 to the power of 2. Therefore, substitute. Minus 1. So when it goes to the denominator, it becomes minus 1 square plus 1 by minus 1 to the power of 1. Next, plus summation formula. 1 minus minus 1 to the power of minus 1 to the power of n plus 1 divided by 1 minus e, that is minus 1. Next is minus this one, 1 minus 1 to the power of n plus 1 divided by 1 minus a. Next minus 1 to the power of 0 is 1. Next, minus 1 to the power of 1, that is minus 1. That is minus 1. Next, minus of minus 1 square equals 1 minus 1 plus 1 minus of minus 1 to the power of n plus 1 divided by 1 plus 1, that is 2 minus. So here 1 minus a means minus 1 minus 1 minus of 1 to the power of n plus 1 divided by 1 plus 1, 2, then plus 1. Next, plus of minus, that is minus 1. Next, minus of minus plus minus 1 square means 1. This is the answer. Thank you.